Hi everyone, this is Sarah from Hamilton. Today we welcome back Paul Garner and Todd Wood to continue to discuss the scientific issues relative to the historicity of Genesis 1 to 11. Today we focus on Paul Garner's work with the geological evidence. Garner contends that while there are significant unresolved problems and unanswered questions, creationist scientists have made substantial progress in understanding the world from a perspective that is consistent with the history narrated for us in the early chapters of the Bible. If you enjoyed this content, please consider supporting me on Patreon or as a paid Substack subscriber. Your support is the only way I can continue to produce a high volume of high-quality content. At $5 a month, either on Patreon or as a paid subscriber on Substack, you get access to all of my exclusive reflections on Scripture. I post 6 days a week, every day except Sunday, 2 to 5 pages a day, and 3 of those are for everyone, while 3 are for patrons and paid Substack subscribers. At Tier 2 of my Patreon, or $10 a month, you get all of my writings that are exclusive, but you also get my weekly book reviews and discussions, each of which is about 30 to 45 minutes in length, and discusses not only the content of the book, but seeks to integrate its insights into a broader theological synthesis. Finally, at the third tier, $35 a month, you get access to all of my exclusive content, written and video alike, but you also are able to have a one-on-one 60-minute call with me every month as long as you remain a patron, if you desire to take advantage of this feature. Your support is much appreciated, both in prayer and on Patreon and Substack, and I ask that you continue to pray for me, and I hope that you enjoy this content. Now I want to get into the nuts and bolts a little bit on the scientific questions. So, Paul, your area is more geology, and Todd, your area is more biology, but both of you guys are kind of involved with each other, and these questions are interrelated. So I'll start with some geological questions, but either of you guys, both of you guys can comment on them if we're good with that. So can we just start with some prima facie scientific reasons that we have for thinking that the sedimentary record, or at least a significant portion of it, can be explained in terms of the biblical history, especially Noah's flood?
Yeah, sure. So, according to flood geology, the creationist idea of flood geology, much of the Earth's sedimentary rock record was deposited rapidly during Noah's flood rather than slowly over time spans of hundreds of millions of years. And of course, that's a very bold challenge to conventional thinking about how the sedimentary rock record was formed. But I think there are some good reasons to at least give it some serious consideration. So take, for example, the very remarkable extent of many of these sedimentary rock units. In North America, for example, there's a remarkable blanket of sandstone. It's Cambrian in age. It extends from the Mexico border in the south right up into Canada in the north, from California and Nevada in the west right through to New England and Maine in the east. In Grand Canyon, we call it the Tapete sandstone, but it's actually given a variety of local names, in other places. So we have this enormous sort of blanket of sand, but it's even more remarkable than that because a similar sandstone can be found at basically the same level in the geological record on other continents, in North Africa, in Europe, and across the Middle East, in South America, and so on. And in some of these other places, it even sits on top of eroded basement rocks, just like the Tapete sandstone does in Grand Canyon. So we've got this kind of global signature. And we see this throughout much of the geological column. We have these remarkably widespread rock units, and we see similar patterns globally from one continent to the other. And obviously, if you have a global signature, that sort of demands a global explanation. And as creationists, we believe that we have a global explanation in the form of the worldwide flood that took place in the days of Noah. So that's one thing. And then, of course, as you begin to look at those sedimentary rock units, you find that they contain marine fossils very often. And these marine fossils are often very far from the ocean and far above modern day sea levels. So at some point, the oceans of the world must have transgressed onto the continents, onto these high, upstanding continents. And we also find evidences within these sedimentary rock units of rapid deposition. These sediments were often deposited quickly. We see evidence of remarkable fossil preservation that seems to demand rapid burial. We see evidence of sedimentary structures like cross-bedding and other things. And we can find these evidences that point to not only these sedimentary units being remarkably widespread geographically, but also having been deposited quickly. And we find similar evidences not only in the Tapete sandstone, but as you go up through the column, you'll find similar evidences, right through the column. So one of the things that we would have to do in order to preserve the conventional geological timescale, which is largely based on radioisotope dating, if so many of these rock units were actually deposited quickly, is we would have to infer lots of time in between successive sedimentary events. So in any one place on the Earth's surface, if you look at a stack of rock layers and you look at those layers and you say, well, most of these layers were catastrophically deposited, where is the geological time? It's got to be in the hiatuses, the gaps in between each of these sedimentary events when erosion was happening or no sediments were being deposited. And that becomes, I think, somewhat problematic when, in many cases, you don't find evidence of the time that should have passed in between sedimentary events. We don't see evidence of the deep erosion or weathering. We don't see evidence of biotubation, in other words, the churning up of the sediments by organisms, things that should have happened if there was some passage of time in between sedimentary events. And so I think when you begin to sort of put all of these observations together, you can begin to build a kind of cumulative case that the flood provides a better explanation for these major features of the Earth's sedimentary rock record than the conventional explanation of, slow deposition over long periods of time.
Yeah, that's really interesting, and I think it's interesting that you talk about the geologic column because there are still a lot of people out there who say, as creationists or folks that think that creationists reject the idea of the geologic column. But I think it's kind of striking, the fact that you do have something which you can document globally is prima facie a pretty good signature of a global event. So the geologic column lends itself, perhaps more than other things, to creationist interpretation.
Yeah, I think that's right. And I think in the past, where creationists have often sort of rejected the idea of the geological column, and it's still a common thread that you see in sort of popular creationism today. I think in effect, we're kind of shooting ourselves in the foot because it's the geological column that actually gives us those global patterns that require some kind of global explanation. And so I think the geological column is the creationist friend. It's not his enemy.
So, I mean, these data points that you've mentioned, what's your read on how they are taken conventionally? I mean, conventional geologists are aware of this stuff. What's the state of the discussion on from their end?
On the kinds of observations that I've just talked about,
Yeah.
you mean? Yeah, so there's a guy. I mean, he's dead now. A few years ago, he was a very prominent geologist here in Britain called Dr. Derek Ager. He was president of the Geologists Association. He was a former head of the geology department at Swansea University. And he wrote a book called The Nature of the Stratigraphical Record. And actually, he makes lots of the very same observations that I've just sort of set out. He talks about the remarkably widespread nature of sedimentary rock units, He talks about evidence of catastrophic deposition, that this is the predominant mode of deposition that we see throughout the Earth's rock record. His solution to this is to propose that a kind of model of neo-catastrophism. So, he's still sort of wedded to the conventional geological timescale based on radiometric dating. So he sees the kind of rare events, the kind of catastrophic events, the tsunami, the storm, the hurricane, as the events that leave a signature in the rock record. But these are rare events, so they're interspersed by long periods of time when not much happens. He likens the history of the Earth to the life of a soldier. He said the life of a soldier is long periods of boredom interspersed with brief moments of terror. And he says this is what the Earth's history is like. But of course, this presupposes that these long time periods in between the sedimentary events are real. And I think there are some good reasons, to question that assumption. And it's interesting to see recently, there was a book that was published. It was a symposium, I think, of conference papers published by the Geological Society, where they talked about the need to infer time gaps, hiatuses on all scales throughout the entire geological record, almost sort of fractally distributed throughout the geological record. But it's interesting, they said these time gaps are often cryptic. They're hidden, because the evidence often is not obvious that this passage of time happened. And so I think there are some really, some interesting things that you can read in the conventional literature that make many of the same points that I've made. This is not news to geologists. But of course, we have a different framework for then interpreting those observations.
So I do want to get to the question of radiometric dating, because I know a lot of people have this on their mind. You mentioned it, but before we do that, I want to ask you, where do you mark the boundary between the onset of the flood and then the after effects of the flood? Because I know a lot of people kind of assume that creationism says the entire sedimentary record was deposited by the flood. What's your read on this question? And do you think there's a consensus that is developing or has developed within professional circles on this?
Yeah, so much of the Earth's sedimentary rock record, I think, relates to the flood, but we also have other events in biblical Earth history. We have Creation Week that may have involved geological processes, the formation of the world's continents, the uplift of the continents, maybe deposition of sediments, and so on. We have the pre-flood world, where there was presumably sedimentary deposition going on in shallow oceans and other environments. So not all of the record is related to the flood. And then, of course, we've got the post-flood period. So after the flood, there must have been some period of recovery. A catastrophe on the scale of the flood doesn't simply end. And, it's not like the children's storybooks where Noah comes out of the ark and the rainbow's in the sky and the sun's shining and everybody's smiling. I don't think that was how the end of the flood was at all. So where are those boundaries? Well, let's think about the end of the flood, because that's the one I think that people get really sort of exercised about. There's lots of discussion about this. My view is that the end of the flood, the flood post-flood boundary is probably somewhere around the end of the Mesozoic. So that's roughly where the dinosaurs disappear from the record. So below that boundary, we have dinosaur fossils, and above that boundary, we don't have dinosaur fossils. And there are a number of reasons that I think that probably marks the end of the flood. I think there's a change in the scale and intensity of many geological processes around that boundary. I think there's a consistent story in the Cenozoic, that's the rock layers above that boundary, particularly in terms of sort of fossil successions that look like the diversification of animals that had come off the ark. So there's the famous horse series, for example, and that looks to me as if it's best interpreted in terms of post-flood diversification of the horse kind. And there are other things going on in the Cenozoic. There's a decline overall in temperatures, culminating in the Ice Age. There's a shift in vegetation patterns that you can see in the pollen record. So I think there's a consistent post-flood story. And also one of the other things concerns the end of the flood being marked by a very distinctive fossil break. So if you think about the animals coming off the ark, it is highly unlikely that the animals coming off the ark are going to migrate back to the very places where their pre-flood ancestors just happened to be buried during the flood. So we wouldn't expect there to be a continuous fossil record of those ark animals at any one location on the Earth's surface, kind of going through the flood, post-flood boundary. We'd expect there to be a break. And the Cretaceous Paleogene boundary, that's the end of the Mesozoic, to me, that seems like a pretty good candidate for that kind of fossil break. I think if you want to put the flood boundary higher in the record, as many creationists do, I think you run into problems that you have too many fossil taxa that are crossing that boundary. It becomes sort of unreasonable to think that that's where the boundary is, because there's just not enough of a fossil discontinuity. So that's my view. I think it's around the end of the Mesozoic. But I have to say, there are plenty of creationists who disagree with me. They want to put the boundary either higher or lower, in the record. I don't always find their arguments persuasive, but it's a complex question, and I think whichever position you take, there are big questions and unresolved problems. And at the ICC this summer, I was one of 7 speakers who took part in a roundtable discussion about flood boundaries, and there were a range of different opinions expressed about both the beginning and the end of the flood. And at the moment, there's not much consensus. I think there's still a lot of disagreement among creationists on this question.
Sure. So let's get into radiometric dating. This is the big argument, a big piece of evidence that a lot of people will point to with some justification as the knockdown for the conventional timescale. Could you just tell us a little bit about the state of creationist research on this question, and talk about the RATE project? You guys have a whole episode on Let's Talk Creation about this. Could you just summarize for the audience, what is this, and how does it relate to radiometric dating?
Yeah, we're doing a whole series of episodes on radiometric dating because it's such a huge topic. It's kind of hard to know how to summarize it here. But basically, radiometric dating uses the decay of naturally occurring radioactive isotopes as a kind of clock to estimate the age of formation of the rocks and minerals that we find in the Earth's crust. So that the way it works is you have a radioactive parent isotope, and it's unstable, so it decays eventually into a stable daughter product. And if we know what the initial conditions were, and if we can measure the amounts of parent and daughter isotopes in the rocks today very accurately, which we can, and if we assume that the system has been essentially a closed system and that the decay rate has always been constant through time, then you can use that to estimate, when those rocks and minerals containing those isotopes formed. You can measure the ratios of the different isotopes in your sample, and you can use it to infer an age. And typically, radiometric dating yields ages in hundreds of thousands to millions or even billions of years. So it's a big challenge. It's one of the biggest challenges that we face as young age creationists. What do we do with these radiometric dates? And what do they mean? Is there another way to interpret them? So you mentioned there the rate group. The rate group, rate stands for radioisotopes and the age of the Earth. And it was a group of scientists, geologists, and geophysicists and others who were convened back in the late 90s by the Institute for Creation Research and the Creation Research Society. And they were commissioned to do research on this problem of radiometric dating. And they published a big book in the year 2000 where they laid out a number of research projects that they were going to do to investigate this whole question. And in 2005, they published another big book where they published the results of the various pieces of research that they'd done. And basically, to kind of cut a long story short, they came to the conclusion that a great deal of radioactive decay had indeed taken place in the history of the Earth. Millions of years worth of radioactive decay at current day decay rates. And they base that conclusion on physical evidence of, the scars of decay, if you like, in the rocks and minerals themselves, and some other lines of evidence. So they said, yes, a lot of decay has happened, but they argued that nuclear decay rates in the Earth's past have not been constant. So they argued that during Creation Week and during the flood, decay rates had been accelerated. So in effect, the radioactive clocks were ticking much faster than the radioactive clocks are ticking today. And that would mean that radioisotope dating methods are giving ages which are too old and would need to be recalibrated within a creationist model. And that's a pretty radical conclusion. So people have, always said radioactive decay rates, you can't alter them. They're kind of fixed. You can maybe, they can sometimes, under extremes of magnetic fields or temperature or pressure extremes or whatever, you can alter them by maybe 1 or 2%. But basically, they're constants. So that's a kind of radical suggestion, and it would seem to be a sort of wild, ad hoc idea, were it not for the fact that the rate group presented a number of lines of evidence from their research that seemed to indicate that something strange was happening with radioactive decay rates. I won't go into all of it now, but let me give you just one example. So they commissioned radiometric dates on a number of rock units, and they dated each of those rock units with multiple radiometric methods, because radiometric dating is not one method. There are actually a whole sort of suite of methods. So they used a whole set of methods on each of these rock units. And if radiometric dates are telling time accurately, you would expect that they would broadly give the same answer on the same rock samples. But that's not what the rate group found. They found that the results of these different radiometric methods very commonly disagreed, often by substantial amounts. But what was even more significant is that there was a pattern to the disagreement. There was a systematic trend. So certain radioisotope dating methods consistently gave older ages than other radioisotope dating methods. There was a very distinct pecking order, if you like, in the dates that were produced. And they argued that when you looked at that trend, it looks as if isotopes with longer half-lives tended to give older ages than isotopes with shorter half-lives. And isotopes that decayed by alpha decay gave older ages than isotopes that decayed by beta decay. There are these different modes of decay. And they said this could be explained if these isotopes were accelerated, and they were accelerated to different degrees depending on the mode of decay and the length of the half-life. And so here was an explanation for this characteristic pattern. So that's basically what the rate group did. And more recently, this was something we presented at the ICC this year. I worked with a couple of students from Cedarville University, where we began to analyze a very large database of radioisotope dates. There are about, I think it was 18,000 rock units, 30,000 radiometric dates from across North America in this publicly available database. And we did a kind of study to see how common disagreement was between different radioisotope dating methods, and also to see whether we could identify a similar pattern or trend that the rate group had found. And indeed, in our very preliminary analysis, and it was preliminary because the database turns out to be quite messy and it needs some work to clean it up. Nevertheless, we did find evidence that pattern exists in that database. There does seem to be a systematic trend where certain methods consistently give older ages than other methods on the same rock samples. So there's something very funny going on, and we don't fully understand it, but there's something worth investigating here, I think.
Yeah. One of the things which is quite interesting to me, just about this and a lot of other kind of unsolved questions, and this is just kind of a broad level observation. It seems to me that a lot of the unsolved questions relating to creationism have to do with heat, and that whether you're talking about plate tectonics, whether you're talking about the heat given off by radiometric decay, a lot of different kinds of research questions generate this same issue. And so I don't know, I wonder if at some point in the future, something is going to be discovered on a physical level that will answer these various different kinds of questions. So I think that's a curious little pattern that seems to emerge.
Yeah. You're quite right. The heat problem is a big topic. Todd, you were going to comment on that, I think.
I think, when you think about radiometric dating, that always strikes me, in discussions about this issue, the radiometric dating has always struck me as sort of the silver bullet, right? This is what makes creationism utterly, impossibly implausible, which is fascinating to me because we haven't even been doing radiometric dating for a century yet. I mean, it was really sort of fully developed in the 1950s. So, 75 years of this research now. And I can understand how, a lot of people would see it as decisive, but sometimes I wonder, and I think this is probably true here, whether the solution to radiometric dating is not embedded into a larger creationist understanding of physics and the origin of the universe and the structure of the universe that we live in. And it may not be a matter of using what tools we have now to solve radiometric dating, but rather reimagining what physics and cosmogony and cosmology really are. And then the solution to these other issues will just sort of fall out like, oh yeah, that explains that, and then that's just going to be the end of that. And yeah, I think there's the stuff that we've generated in this area and the research that we've done, I think, is largely sort of picking up those anomalies and trying to make sure that they really are anomalies. And then those anomalies are going to be the fuel for the next paradigm that comes along that actually sort of resolves all these sorts of questions and objections that people have had for so many decades now.
Right.
Yeah.
Right. So speaking of those ongoing questions, Could you just give me a bird's eye view of the some of the responses and reactions of the rate project from a conventional point of view, whether they raised any good critiques? What's your read on the fallout from the rate project?
Yeah,
most of them ignored it. Most of them just
yeah.
ignored it. I mean, that was just those crazy creationists after doing stuff again.
Yeah. That's often the case, isn't it? That creationist research is just overlooked. It's just not paid attention to. Yeah, that's certainly true. There were some critics who sort of responded to it. There was one article, and in fact, we talked about this a bit on our podcast, by a physicist called Randy Isaac, who wrote an article in the Journal of the American Scientific Affiliation, where he sort of responded to a number of aspects of the rate project. And I think when I read that, I felt that he had sort of missed the point on quite a number of the topics. So, for example, when he was addressing the rate stuff about sort of systematic discordances between the results of these radiometric dating methods, he just said, yeah, but you've got to weigh this against, the vast amount of concordance that exists. And the discordances, they only amount to sort of 10 to 15% or something like that. And I think it sort of missed the point, because it wasn't so much the amount of discordance that the rate group were pointing to. It was the systematic trend in discordance. And he didn't really address that at all. He didn't sort of talk about that topic in the paper. And also, it's interesting, when he talks about the vast amount of concordance, he didn't cite any literature to support that claim. So how do we know? That was my question. How do we know how common concordance and discordance is? How many studies have been done to really try and pin that down? And that was one of the questions we were trying to address, in analyzing this big North American database, to try to get more of a handle on that question. And he made some other similar criticisms. I think you're right that there are some cogent criticisms of rate. There are definitely some areas that where we have unresolved problems. One is the heat problem, which you've mentioned, because if you have a huge amount of radioactive decay compressed into the year of the flood, that generates lots of heat. In fact, as best we can tell, it generates enough heat to vaporize the crust of the Earth, maybe multiple times over. So that's a huge problem. But I tend to think rather like, Todd here, that perhaps there's some grand unified theory of creationist cosmology or physics that we're not there yet. And I think some of the solutions to some of these problems might kind of drop out of those sorts of theories. And one of the other sort of cogent criticisms I think of rate is, what about the radioactivity problem? So you also have the hazardous effects of all of this radioactivity. And, is the 8 people on the ark and the animals on the ark, are the floodwaters enough to shield them from the radioactivity that is going on in the rocks below them? But then, even if you can solve that problem, you've got the question of radioactive isotopes like potassium-40, which we actually have in our own bodies. So how are they protected from the hazardous effects of that radioactive potassium decaying within their own bodies? So there are these unresolved problems and areas where we need to do a lot more research. But we still need to grapple with the other data that the rate group presented, the helium diffusion work that Russ Humphreys did, and the polonium radiohalo work that Andrew Snelling has done, and the systematic discordances. There are things here, there are observations here that need to be explained, and we can't simply dismiss it. I think we really do have to think seriously about it and think, what are the various options for explaining the whole range of data?
Right, right. Yeah, some people say creationism is just a series of promissory notes, but at the risk of oversimplifying things, I've said to people, promissory notes are okay if there's a precedent of fulfillment. And I think this is one of those cases where we can show there has been actual progress that's been made. That gives us good grounds to think there's going to be more progress which is made, which is how any scientific model shows itself to be a sustainable model.